Hello everyone and welcome to this demo video of the topic Prepost. My name is Vijay and I'll be glad to take you through our project today. So it's no secret that social media is now a big part of our lives and has empowered a lot of creators around the world. However, it does come with a few perils. Nowadays, a lot of images are being uploaded to social media, some intentionally, but some unintentionally being used for location revealing purposes. Recent research has shown that there's a lot of privacy leakage in large scale model training, and bad actors can use these images not intended for location revealing purposes to dox them or harass them. Well, can we flip the switch? Can we use these large language models or large vision models to help inform the users, be aware of these privacy risks, and help inform them make better decisions about their posting? That's where we come in. Welcome to Prepost, where you plan before you post. Here are the main features of our app. You can first check and flag for potentially location revealing clues in an uploaded image, and we use the new state of the art GPT-5 model for that. And then after that, as a quality of life improvement, we also offer suggestions for cool and targeted captions for the accompanying posts. So here's the architecture diagram where the user uploads an image like this mosque in Istanbul, for example. We use GPT-5 to infer these two items, location information clues, and some tips before posting. And then we use a combination of Llama Vision and Lava to identify the main topics of the image and then generate captions based on that. For this, we used AIML API, the OpenAI documentation and the OpenAI API itself, and also a bit of Olama for testing locally. Two main features I want to highlight about the prompting strategies we used. So since we're using a GPT-5 model, we also made use of the OpenAI feature to improve prompts. It's called the prompt optimizer, and you can see here how the prompt we use was improved and hence gave better results. And another thing I want to point out is we did a pretty extensive literature study on this particular topic of geolocation in large models. And these are the artifacts which large models have been seen to refer to the most. And hence we use these particular points to create more of a few short prompt in our particular application. Now, that being said, let's look at the app itself. We force it on Streamlit, and I'll just clear the page and make a new one now. So we can browse file and we can upload any file. This there is no server here and no storage here, hence it's preserving the privacy as well. So we can see that we've uploaded an image now, and you can see that the model is running. So this will call GPT-5, and there's a little bit of API inference runtime. So let's have a look at the outputs as and when they come. So if you recall, the first step is to get the clues for location and also the potential tips that can help. So for instance, if you had a windowsill which has a location information on it, this could help solve that. So let's have a look at the outputs. Yeah, so you can see here that we have JSON formatting here, and we can see that we have an institutional marker for the gold plaques with Arabic script and so on. And we can see that the location has also been relieved. We have the Turkish location and we have Istanbul. This happens to be a mosque in Istanbul. Similarly, we can also see the suggestions before posting, for example, using filters or editing techniques, and it also gives you targeted suggestions on what to light and what to change, so on. And once you've done all these steps and you want to post it, you could have some sample captions which have been grounded on the image posted here. So you can see you have, allegories to Turkey and so on and so forth. So this is an end-to-end tool that we have deployed using Streamlit, and we're excited for you to try it out and let us know your feedback. Now, what is the future work for this? Well, one direct future work is using adversarial attacks. So as illustrated in the image here, for the other task of image classification, we can add the human imperceptible noise to an image, and that will generate the model and give the model these wrong signals to get the wrong outputs out. So you can see the panda here, when added to the small noise, becomes a gibbon in a state-of-the-art image classifier. We are now actively researching techniques to implement this for models that do geolocation. So once we do that and we get a performant model, we can then integrate it into the pre-post pipeline. So that concludes this presentation. Thank you so much for listening, and we're really open to your comments and your feedback about the project. As usual, the links will be in the description. Thank you.